Hello, I'm Manmeet Singh from Chitkara University. I'm in my third year. My course is computer science, and I chose the theme Order Busters Knowledge Capturing AI System. All right, so let's begin. So, the problem I'm solving here is the experience of a person, a human who trained himself in a specific industry for years, made thousands of mistakes, trained his judgment, his intuition, all of that. We need to take that and put it into a system so it guides the younger generation, the new folks. All right. We are doing this because in Japan and in any country, or in any country, when a senior professional with all of that experience retires, the knowledge with which he produces high quality output is not getting passed down. So to do that, we need a system that captures that experience and trains the inexperienced folks so they can achieve the same level of output. All right. So to do that, we need to understand that there are two types of knowledge. One is factual knowledge, the data, facts, all the company data and all of that. Next is asset knowledge. This is what we're solving the problem for. For this problem, we already have an existing solution in the market. So we will solve this problem, which is experience, transferring experience, right? The quality judgments, the trained intuition. So how do we do that with AI? We, we created a system, a simulation model using knowledge graph and a concept I called chain observer, right? So let's assume after all the system, this big system, we have a domain specific AI expert. We query that AI expert with a problem, right? Which is, let's assume I'm a ramen shop in Shibuya and I query this. How to reduce salty balls at Shibuya store at less than 3 minutes a day, that is less than three negative reviews a day in 14 days and keep average wait less than 5 minutes, right? Now, even though the situation is specific, it misses a lot of variables and possibilities. There are a lot of unclear things that the LLM doesn't know, right? The model doesn't know, which is tear, like seasoning, soup boil, noodles, temperature, and each of them have a possibility, which is like ball, target 32 grams by scoop. Like the level should drop by 10% for during boil during rush, all of that. So each variable need to be taken into consideration to give a good outcome, right? A satisfactory outcome. So what we do here is we take a query, we take the query, pass down, we do two things with it. One, we pass down through general LLM. Then we create multiple variables out of it. We divide this query into sub queries and we create like these queries we saw here. We divide this into multiple sub queries. Then when we have all of those sub queries, those questions clear, we automatically create a situation. Then we take the initial hypothesis that was generated by the general model, we test that against a situation which is now in the simulation place, right? This is called simulation. We are testing the hypothesis against the situation. Now, this situation will go against now the simulation will happen and there will be a threshold test which will be done by the human in the loop. So the test will happen, and in the threshold test we will see did it pass or did it fail. If it passed, it goes to our knowledge graph. The knowledge, okay, and if it fails, it goes to a place called chain observer. Now the chain observer has all of these context points, which is initial hypothesis, what was that, previous hypothesis, if any, what went wrong and why it went wrong. Now all of this data is taken by the chain observer. He now what chain observer does is it spots the why it went wrong part, all of the weak areas. It makes the observations like did it fail? Why did it fail? What was something missing? Did I need to reduce my staff? Did I need to do this? All of that. It takes that query and it makes new observations. Then it creates a new hypothesis, right? And that done. Now at this stage, how now that is tested against the threshold test. Now, here's how the chain observer works. See, chain observer. It works. How this works is first observer failed, created a new hypothesis. Second observer, now second CO2. Second observer has the data for the previous observer. Why it failed, what was the initial hypothesis, the observations made, all of that. Now this is failed. This is again. Now each time I'm adding a chain observer, a new observer, my knowledge graph, which is the big brain, which is where all of the experience is getting added. The AI is living the situations, it is making mistakes, and it is storing all of that new information in the knowledge graph. Right? The each time chain observer comes, our knowledge graph keeps expanding. So the job of each chain observer is spot the areas where the previous hypothesis failed, understand why it failed, make multiple observations that weren't made before, create a new hypothesis targeting those areas specifically, and correct if any mistake is repeated before. All right. Now, when I do this, I will do this multiple iterations until this will keep iterating until a satisfactory result is reached. The threshold test, the threshold score is reached, or timeout happens. Now, when the threshold score is reached, right? We reach the threshold score. At this point, we already have our AI expert ready. Okay, the AI expert is done. Ready. It is ready. What happens is, with that threshold score, when the satisfactory result comes, we know that the chain observer 3 or nth chain observer, maybe 7, maybe 11, maybe 21st chain observer, that chain observer who is making the new hypothesis already has the data which is much richer after making many mistakes. It is much richer than the one we had here with the general LLM. All right. So we already have an AI expert at this point. Now what will happen when we can either use this directly, or if we want to increase the accuracy of this further, now what will we do? We will input multiple queries which were created here, hundreds of queries, thousands of queries. We will input those queries and we will get the output of them, right? Now when we get the output, we will get many data sets. So we have solved the problem of data sets. We can get infinite number, unlimited data sets here, and we can do one fine tuning job. Before we had to do multiple fine tuning jobs, so we will do one fine tuning job. So the cost of that has reduced by 70 to 90%, right? Multiple fine tuning job, and when the fine tuning is done, AI expert is ready. So the next time a new employee or a company comes of any industry, any query, it will solve the problem by this AI expert, the trained one. Thank you.